Today I'm going to talk about um, Route 53 and um, AWS messaging systems. So uh, let me begin with Route 53 first. So Route 53 is basically a domain name systems which is provided as a service by AWS. This is Route 53 is highly scalable and highly available as well. So to understand Route 53, we need to understand what domain name system means. So I'll give a quick primer on domain name system and jump into Route 53. So domain name system is nothing but like a phone book for the internet. You know, basically, you might be knowing how phone book works, right? So there will be index, there will be uh, name and phone number associated with it. Similarly, we will be, for humans to access the resource, we need to uh, find uh, a pattern where we could match a name with the resource address. So basically, resources are identified by IP addresses, Internet Protocol addresses. So we have devised a mechanism where we could relate the actual names to these IP addresses. So DNS helps in translating the domain names to IP addresses. So whenever we type address something like www.wikipedia.com, there are a lot of uh, machines and servers which helps us finding the right uh, resource and gives us the IP address, and we use that IP address to talk to that resource. Here, you see that here's an example of I've taken a Reinvent 2017 example where when you click on reinvent2017.com, it would talk to the DNS resolvers, and the DNS resolver would give an IP address instead of www.reinvent2017.com, and our browser would use that IP address to talk to that resource. So devices are basically connected to the internet with the unique IP addresses, so there won't be any uh, duplicacy in IP addresses, which we have already discussed. So the IP addresses are always unique in the system, which will help us to actually target the resource and communicate to that resource. So this is how DNS query propagates. So we will take an example of, uh, in this example, we are taking www.wikipedia.org. So as soon as you hit this URL in your browser, it would talk to your DNS resolvers, and DNS resolver would actually talk to uh, first it would check in its cache if there is any IP address associated with it. If it is not present, then it would talk to DNS iterator. This DNS iterator would request the root name server. So the root name server starts with a dot. So root name server doesn't have any um, you know anything associated, but that would be the first server that it would talk to. So root name server would give the you know the next level of name servers which it has to talk to. So root name servers will have all the details related to the different uh, domains. They are called top level domains. So top level domains are com, org, net, something like this. So uh, the last part of your URL would be the top level domain. So it would give the IP address of the top level domain, and the DNS iterator would again talk to that top level domain, and top level domain will give back the IP address of the actual um website, or the um the name server which holds the domain name, and domain name would contain the actual resource IP address. So that would it would give back the actual IP address of the resource. So your browser uses that actual IP address and communicates um, with that resource. Next time when it talks to uh, when next time when you hit the URL in your browser, the browser again speaks to your DNS resolver. Mostly the DNS resolvers are present from your ISPs, so internet service provider. So it would be present in your ISP and it would be cached. So it would give back the resource uh, IP address immediately. So here's a simple hierarchy of name servers that your the request would traverse. So first it will go to root name servers, then it goes to top level domain, then it goes to domain servers, and within domain servers it would communicate with its own name servers which has subdomains. So this is the hierarchy of your query propagation. So here is a more pictorial way of representing it, how it communicate, how the DNS query propagates. So we've already seen how a regular you know DNS propagation works. Let's see how Route 53 routes its traffic for your domain. So when you say www.example.com, and if this example.com is registered with Route 53, then it would uh, the request still goes to the DNS resolver. This is your ISP provided by ISP. ISP stands for Internet Service Provider. So it can be, in my case, it can be Airtel, or in your case, it can be ACT or something like that. So the third step it would go to DNS root name server, and it would say go and you are asking for the next or you know top level domain, that is uh, the .com server. So it would give the IP address of .com servers, and that would the fourth step would be to communicate with the top level domain name servers, and this time it gives the uh, IP address of Route 53 name servers. So top level domain names knows where the domain is registered, so it would route to Route 53, and Route 53 here evaluates the uh, domain name, and it would give back the IP address of the IP address configured in Route 53. So once you get the IP address, the browser will actually communicate with the actual resource, and it would get back the response from that resource. You could use a simple tool called Simple DNS to find out the steps that are involved. You could use this URL, and I'm not going to do that as of now for to save some time. So let's understand what Route 53's core capabilities are. So it does domain registration and renewals, and it maps domain names to resources. These are the primary capabilities that I could say. Basically, registration of the domain and uh, domain names mapping to the resource. But it also provides health check, which basically it will route the traffic from uh, route the traffic to healthy endpoints, and if there are unhealthy endpoints, it would not route the traffic to that particular resource or endpoints. So we can also create something called as private DNS, and this would not be visible to the outside internet. It would be part of your VPC alone. So the visibility of that DNS would be within your VPC. So there is also a new functionality provided by added to Route 53, that is global traffic management. This gives you a visual um, environment where you could see how the traffics are, how the route is configured, and you could set up more traffic policies and route policies. So Amazon Route 53 has three main concepts, as I said earlier. So the mm, domain name registration concept, um, domain domain registration, domain name system, and health checking. Let's see what are its what are the functionalities or aspects involved in these concepts. So when it comes to domain registration, the first thing we need to understand is domain name. So domain names are names such as example.com. So understand that uh, www dot is not part of the domain name. The domain name would only be something uh, before the dot of top level domain and the top level domain. So anything after the first any prefix would be called as subdomains. So domain registrar is basically a company that is accredited by ICANN. So this is an international organization to process domain registration for specific top level domains. And Amazon is also a registrar. Sorry, Amazon registrar is also a domain registrar for .com, .net, and .org domains. It also has an associated uh, registrar called Gandhi, and it has a few more top level domains attached to it. So there is also something called as domain registry that we need to understand. It's the uh, company that owns the right to sell the domains that have a specific top level domain. So for take an example, the VeriSign is the registry for .com TLD. So there are many companies that owns the right to sell um, the domain, and they are specific uh, to the top level domains which they are associated with. There's also something called as domain reseller concept. So a company that sells domain names for registrars such as Amazon registrar. So Amazon Route 53 is a domain registrar, domain reseller, and it would communicate with Amazon registrar for registration or selling the domain names um, for that registrar. So as I said, there is also another registrar associate called Gandhi. So top level domains is the last part of your domain name, such as .com, .org, or it can be anything. So there are two types of top level domains. One is generic top level domain and geographic top level domains. So generic top level domain can be anything. Here I've given an example of .bike. Geographic top level domains are associated with geographic locations, areas such as countries or cities. Here the .in represents India. So all these are not specific to any or they're not confining you from choosing any of these domains, but these are top whenever you choose top level domain, it is best to uh, choose which actually resembles your business, or which is appropriate to your business. Let's understand some concepts of domain name systems. So domain name has not many concepts. We'll go understand each one of them. So there is something called as alias record. So this is a type of record that is created, within Route 53 to route traffic to AWS resources, but not actually the to the IP address. So what it means is you could associate any AWS, some of the pre-configured AWS resources to the domain where these resource IP address might be dynamic, but the resource itself would be attached to the domain name. So uh, in such situation, we would use alias record. So authoritative name servers are basically name servers that have definitive information about one part of the domain name systems. So basically, it would say uh, uh, the whenever the DNS resolver is communicating with it, so it would give the next level of information or next set of name servers to be communicated with to the DNS resolver. So it would be somewhere in between uh, Route 53 and the root name servers. So DNS query is basically the request that is submitted by any device, and DNS resolvers are often managed by your ISPs and are in between uh, your system and the domain name servers name systems. Okay. So domain name system actually translates names into IP addresses. Hosted zones are uh, part of your Route 53 uh, web service. So they contain records which includes information about the uh, route for the domain to the resource. So basically, uh, let's say if we have something like this would contain something like www.example.com, and it would also contain the corresponding resource details. So name servers are the servers um, to translate domain names into IP addresses. So in Route 53, you would get, as soon as you create your domain name, you would get 4 name servers associated with the domain names. So private DNS is basically your local version of domain name systems. So which would you know provide a virtual um, domain name system within your VPC. So it is best used to identify resources within your VPC. So let's understand what record means. So any item which would be part of your hosted zone would be a record. So that would contain um, your uh, domain name domain name associated with your uh, resource. So basically, it tells you, it defines how to route the traffic for your domain or subdomain. So there is something called as reusable delegation set. So these are uh, again these are four authoritative name servers which are part of one hosted zone, which can be reused or reassigned for your new hosted zone. So subdomains are basically labels which are prepended to the registered domain name. So in this example, www.example.com, you could say www is the subdomain. So time to live is it's the amount of time in seconds that you want your DNS resolvers to cache. So, as I told earlier, DNS resolver, which usually will be part of your ISP, would cache your domain name to IP address mapping details. So you can set uh, the cache duration in the Route 53 console, where um, it would cache for that particular amount of time. So the longer time to live reduces your Route 53 charges, because the number of times that it has to be your Route 53 has to be communicated for the domain IP mapping would be less. So it would save you some cost. So usually it would be somewhere around 24 hours. So let's understand some routing policies that um, Route 53 provides. So there's something called as simple routing. Basically, this is used when you have a single resource performing a function. So what it means is there might be a single EC2 instance, there might be single load balancer which has many resources, but still there is just one endpoint for the your domain if you're configuring it to ELB. So whenever you have one endpoint, you could use simple routing policy. So there's also something called as failover routing. So basically, it uses active passive pattern. So what happens is, if your primary endpoint goes down, then traffic can be routed to secondary endpoint. So this is usually done when you are looking for high availability for traffic. So you have two endpoints or two instances where if you where you keep checking the health of each instances. When one of the uh, instance the primary instance go down, you can switch the traffic to the secondary instance. So there's also something called as geolocation routing. So this is used when you want to route traffic to the same geography of users for your users. So basically, this would come in handy when you want your traffic to be only within India or a particular region. You could select country and you say, I want only users from India to access this. Then you could actually meet those compliance requirement using geolocation routing. There is a new policy option that was introduced along with traffic flow. So traffic flow is also fairly new. So geo proximity routing is a new way of routing policy. So this what it does is you can route traffic based on the location for your users, but optionally you can shift traffic, from the resource to one location to another. So if there are traffic, let's say there are um, uh, two endpoints or two edge locations where these resources are present, and traffic is distributed evenly. Then if you want to distribute traffic to one of these locations, you can set a percentage, say 60% of the traffic has to go to India, and 40% has to go to um, servers which are present in Singapore. Then you could do those configuration with geo proximity routing. So you have the flexibility to configure that. So there is also something routing policy called latency based routing, and you use this when you have resources in multiple AWS regions and you want to route the traffic to the region that provides best latency. So this would improve the performance of the um, request and response rate. So there is also something called as multi-value answer routing, where you could configure for the same domain name, you could configure multiple IP addresses with multiple records in your hosted zones. So it would randomly check, and it would route the traffic to that particular uh, resource, and it would also keep it would also keep checking the health of those records, and health uh, whenever the resource is unhealthy, then the traffic is not routed to those resources. So there is also you know routing policy called weighted routing. So you could actually set like what portion of the traffic has to be directed towards um, different resources. So you could set uh, what any proportion of traffic for multiple resources. So this comes in handy when you want to do some A/B testing. You could set 90% of the traffic to um, old system and 10% of the traffic to new system, and um, you could do some canary testing where or um, blue green deployments. So let's quickly go through how our domain registration works. So you choose basically the domain name, whatever you want, and you would search in the domain registrar whether this domain name is available, and it would check in top level domains with servers whether it's available. and if it is available, then uh, your name is registered, and during the your domain name is registered, and during the registration, Route 53 would create hosted zones, and it would assign a set of four name servers to those hosted zones, and uh, these name servers which are part of hosted zone is added to your domain names. So basically, as in when you hit the uh, domain name in your browser, uh, it will trickle down till Route 53, and Route 53 will check these name servers for the actual resource or your IP address which you have configured for that resource. So you could see how internet traffic is routed to your website. There's just an illustration here. You could always check that. So at the end of registration process, AWS need to send your information for the domain. So that would be saved in your domain registrar. That is, in this case, it can be Amazon registrar, or it could be, Gandhi. uh, and most of the domain like .com and .net and .org would be saved in here, Amazon registrar. So finally, the registrar sends the information to the registry for the domain. So the registry is basically they're the ones who sell the domain names. So this registry again stores the information into their own database, and it also stores some of the information in WHOIS database. So let's understand the availability and latency of Route 53. So it uses global anycast network. So it gives you optimal location based network conditions. So it is low latency based network. Each hosted zone is served from its own set of four virtual name servers. So there's a lot of redundancy there. Your uh, resource to domain name mapping is saved in four different uh, virtual name servers, and Route 53 claims 100% availability. We saw that um, in S3 there were 11 nines of availability, but in here Route 53 gives you 100% availability. So these are the service credit if it doesn't give you 100% availability. So if the servers are down for 5 to 30 minutes, it would give you 1 day of service credit, and if it is somewhere between 31 minutes to 4 hours, it would give up to 7 days of service credit, and if it is more than 4 hours, it would give you 30 days of service credit. So as soon as you make any changes to these records in Route 53, changes are propagated to worldwide network of authoritative DNS servers within 60 seconds. So we were talking about a record set. So these record sets are basically part of your hosted zones. So each contains the DNS configuration. These record sets also supports wildcards for your domain names, and these every record set has time to live. Okay, so there is no default time to live for any record type. So if you are using an alias record set, then time to live is inherited from the service that is configured. So yeah, let's say we are using alias record and we are configuring with um, elastic load balancer, and the time to live is inherited from elastic load balancer. So some record types allows you to specify multiple target values as well, which means that you could set multiple IP addresses for one single record set. Let's see what are the record types that are out there. So uh, one important and very basic record type is a record set. So this is where you configure your domain name with the IP address. When you're using IPv4 address pattern, you would use a record, and when you use IPv6 address pattern, you would use um, this AAA record type. So C names are nothing but a canonical alias records. So this is used to assign um, with any subdomains or prefix to your domain names. So it could possibly configure to any uh, DNS or domain names. So MX is basically used for mail exchange record. So if you have a mail server, you could configure it here. So there is also a record type called NS, which will actually hold the naming servers records, and you have a few more record types, and please go ahead and check all of those. So they are mostly SOA is used for saving your um, your name, email, and TTL values, which could be used by your DNS resolvers. There is also another option for reverse IP address tracking, where you give the IP address and you would reach to uh, the domain names. So there is also a few configuration that you could do here. Mm, there are also a few more record types, but most importantly, we would can see that alias is primarily used in Route 53 to point to the specific AWS service. To take an example, we could route a domain name to a CloudFront distribution system, where this could hold some of the resources, uh, or it could host uh, you know S3 website uh, backed application as well. So all all these services, AWS service, can be configured to Route 53 um, domain names using alias record. So basically, they are pointed to AWS resource. So these are some of the alias record pointers which are out there. So CloudFront, Beanstalk, Load Balancer, some of the S3 bucket configured for static website, and you can configure to same hosted zone. Sorry, to a different record set in the same hosted zone. And please note that you cannot set TTL value for these pointers. So it is inherited from these AWS resources. As I said earlier, if there are any IP address changes in your elastic load balancer or other resources, Route 53 will automatically reflect those changes. So let's understand what private hosted zones are. So we already discussed, um, these private hosted zones are part of your VPC only. So they are only visible within your VPC, and it routes traffic for your domains and subdomains within the VPC. They are free to use to any domain names that you want to register. So they, since they are not publicly accessible, you can give whatever names you want for those resources, domain names for those resources. So this will help us in targeting those resources using those domain names. So you could say a development database, test database, and all that. You could configure that in hosted zones, and your service can use those, and it will be easier to remember and configure. So these Route 53 has health checks, as I mentioned above, and if you are using health checks within Route 53, then uh, health checks are usually outside of your VPC. So you need to assign a public IP address to your instance to monitor the health of those instances, or you could do it indirectly through um using CloudWatch metrics without using Route 53 health checker. Yeah, it yeah. So basically, yeah, yeah. So basically, if you have, I have sent this ELB video. If you check that, you could configure that health check to a particular URL. So it would hit that URL pattern, and it would wait for 200 response. So you could it won't wait. It won't check the content, but it would check the HTTP status. So you could configure uh, any path, and the path should return the HTTP 200 response. So you could if you go back and check the ELB video which I had sent earlier, you can see that that is configured using health check. So basically, what you need to understand is health check is like you give a URL pattern, and that URL pattern should return HTTP 200 status. That's all. So that's when it uses the heartbeat pattern where it keep hitting the this URL quite often, and if it is receiving 200 response, it means that 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 system is healthy. That's all. So you could configure health checks at two levels if you want. One is at ELB level and one is at Route 53 level. So what it does is, um, when ELB, when there are more ELBs configured to Route 53, then it can direct the traffic to the healthy ELBs. So this abstraction, the higher level of abstraction, would actually help us in eliminating some of the servers which are uh, uh, part of those ELBs. So if you're configuring four ELBs or three ELBs to the same domain names, so when we are using weighted traffic. Um, so it would eliminate those ELBs completely if that ELB goes down, or some of if the resources in the ELBs goes down. It wouldn't check directly the ELB's health, but here in both ELB and the Route 53, it would actually hit the uh, end resource and find out whether it is returning HTTP 200 response. So in both cases, this would hit the actual resource. I think I have cleared, I have given some understanding on that. So to go with next, item. This is a new feature that is added to uh, Route 53 that is called traffic flow. So this is a global traffic management service for your application. It gives you visual environment, and you could set traffic policies, and these are basically set of rules that you define to route um, traffic to your application, and you can associate these traffic policies to your hosted zone using policy records. Basically, this simplifies the creation of a record set and policies. Traffic flow is basically a expensive approach for managing your traffic, global traffic. But if you are owning more than 20, 30 domain names, this would come very handy. It would cost somewhere around $50 per record set, so it's quite expensive. So when it comes to monitoring, Route 53 has health checks. We already spoke about Route 53 health checks. It sends to CloudWatch at 1 minute interval, and you could take necessary actions if you want to take any necessary steps to handle those unhealthy instances, and if you want to bring back a new instances in place of unhealthy instances, you could do all that. So there are a lot of metrics that are captured. I'm not going to go through all of them, but I've mentioned here just probably check that the most important is health check status. So this would check the status of the status of your endpoint. So CloudTrail actually helps you in capturing every request that is sent to Route 53. So, but the thing is, you have to choose uh, US East, North Virginia region to capture this CloudTrail. So CloudTrail has to be set up in this region particularly if you want to use Route 53 request capturing. So as I mentioned, the pricing traffic flow is quite expensive at $50 per policy record. And if you have any hosted zone which you have created, it would cost around 50 cents per hosted zone per month. So till up to 25 hosted zone, it costs around 50 cents per month, and additional hosted zone costs you around 10 cents per month. And if you are creating a hosted zone for testing purpose, and if you delete it within 12 hours, you're not charged. So if you want to test creating hosted zones, you could do that, and if you delete it within 12 hours, you will not be charged. So queries are prorated, so they are like 40 cents per million queries for standard routing. So standard is basically a simple routing policy. If you have any latency based or geolocation routing, it would cost a different you know different cost. So alias records are record queries are free. So basically this would have um, y- your domain name mapped to the um, your AWS resource. So classic example I could remember, even you could remember, is configuring domain name with CloudFront or ELB. So when it comes to health check, up to 50 AWS endpoint health checks are free. So basically, they are basic health checks. If you want, there are many optional features that could enable in health check, and it can cost a higher rate when you're using. And if you're using particularly uh, non-AWS endpoint, it would cost you more. So before we jump into AWS messaging concept, I just want to you know look at Route 53 demo. So whenever you're registering a domain, you could always check anything. For example, .com. For example, so .com, you have a different pricing for each domain names. Sorry, top level domains. So you could choose based on these pricing range as well. So mostly the cheapest ones are the DE and BE version. So if you see, the BE has $9. So $9 is the cheapest that you could find. In it might change later, but as of now, uh, this is the cheapest. So let's say I'll check with this, say example.com. It would check and let me know whether that domain is available. And it says it's not available, but some of the suggestions. So I would say 1 2 3 just show that. So you could just add it to cart, and you are registered for 1 year. It would cost this much. So you can enable um, renew option as well. So if you want to see the more detailed cost of all this, you could see here in this pricing section. I'm not go through all that. So let's say I'll continue. So you need to give your information here, all of this, and um, you have to verify, and that this will be saved in the registry and who is database. So I have two registered domains here, and these are basically the information that it has. So these are the name servers it has attached. So each is uh, distributed in different availability zones, and you it gives you great resiliency. So it would also tell when it would expire, and the extent how you, when you want to extend, you can extend it from here. So hosted zones are uh, if you hosted zones, you can create whenever you create a domain. Hosted zones are created as well. If you want to create a private hosted zone, you could name it whatever you want. You could say example.com or whatever you want, and you could still create it. So you have to select the VPC that you are associating it with, and it says you should enable DNS host names and DNS support as part of this VPC. Yes, yes, yes. Yeah. No, this is I have already purchased. Go demo.de. Yeah. Okay. 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 Yeah. It's available. Yeah. Yeah. Sure. So these are hosted zones. I've created one private hosted zone now. So as soon as I created a private hosted zone, you get uh, two records. So this SOA records tells all about your information, and uh, this would talk about the different name servers that are attached. So you could create a record set for this using your uh, IP addresses within the your VPC, and it would route traffic to those IP addresses. So for example, I can copy this IP address and just have to add it here, and this would be your um, domain associated with this IP address, and you could always set the time to live in seconds. And if you want to configure to AWS resource, then you would say alias yes along with type A, that you have to associate. You should always use a record when you're using alias, and you could select different targets. I don't have any ELB right now. If you create an ELB, then it would be listed here, or S3 website endpoint, it would be listed here. You just have to select that, and that's it. And if you are um, uh, configuring HTTPS, you could always do that at ELB level, and ELB would take care of HTTPS termination, and uh, it would communicate with the with your domain, and you don't need to do anything else for HTTPS configuration. So there are many um, you know routing policies. Simple is you get to choose only one IP address. So you can use weighted IP address, and you could say what is the weight that you assigned to the target, and you could set any ID here, and you could say whether you want to evaluate target health check, and you could actually set the health check associated with it. So I'm gonna do that. So you could create um, health checks here, and you could configure those health checks. So there are a few configurations that you could do here. This would say what is the endpoint that uh, this health check would refer to. So you could give your IP address, you could give your domain names, uh, and you could also give the path to that resource to check the to monitor your endpoint. And you can see that for basic there is no uh, you know additional, you could say whether it's a basic health check or you have some additional options. So that could be configured here in the advanced configuration. So as I told, there is something called as traffic flow. This has two options: traffic policies and policy records. You set the rules in traffic policies, and policy records associate these traffic policies to Route 53, and um, you could see a visual pattern, something like this. So you could see a DNS name, and you could see failover rule. You could see what is the weighted rule, um, how it is actually configured. So this gives you a visual uh, uh, design of how your resources and your records are configured. And this for each hosted zone, each record set, it would cost around $50. So it's an expensive tool. So basically, this is exactly same as your hosted zones and all that, but it gives you a visual editor, and it gives you additional a routing policy called geo proximity routing policy that is not present otherwise. So that is the main differentiator. You If you want a geo proximity routing policy, and if you need um, you know um, this visual editor, then you would go with it. And another thing is, if you're creating traffic policies and you want to maintain versions of it, then you would use this traffic flow. But other than that, it does the same functionality as you manually going and creating the hosted zones and adding records to it. Yeah. So that is the uh, 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 differentiator here. Yeah. So that is all from Route 53. So let's quickly jump into AWS messaging platforms and messaging services that are provided for our modern application uh, architectures. So AWS provides, when it comes to messaging options, three main services. One is Amazon SQS, other one's Amazon SNS, and uh, the recent is Amazon MQ. There are also a few other messaging options like Amazon Pinpoint, streaming service called Kinesis, and IoT message broker. But we are not going to cover that today here. So mostly we would be covering Amazon SQS and SNS. And Amazon SQ is basically a migration tool, which could be used as a migration tool for uh, migrating your on-premise Apache MQ into um, Amazon. So it is it's actually a variant or homegrown um, active MQ, Apache active MQ service. Yeah. Yes. Thank you. Correct. Mm-hmm. 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 Yes. Yes. Correct. Yeah. Yeah. Yes. Yes. Sridhar, you're absolutely correct. So yes. Yes. We have Elastic Kubernetes Service. Yes. Why? Why is that? Okay. Okay. Yeah, they do provide Kubernetes service. It's called Elastic Kubernetes Service. EKS. Now they have come up with a serverless model of Kubernetes service also. So this year, they have in the reinvent they've launched that Elastic variant of Kubernetes service. Yeah. Okay. Let's move ahead with Amazon SQS and Amazon SNS. So as Sridhar said, Amazon MQ is a variant of Amazon, which gives you a path, a transition path from on-premise to your AWS cloud platform. So this Amazon SQS is a proprietary variant of queuing service. So let's understand SQS first, then let's understand SNS. So SQS is basically a fully managed uh, messaging service for distributed systems or serverless applications. So as we keep speaking about managed and fully managed systems. So we need to understand there is a subtle difference between managed and fully managed. Managed is um, where you set the computation power, or you choose what kind of systems that you need. You say this is the computation power I need, and it would take care of managing that particular service in other ways, like updating the patch or maintaining the right versions of the software, and everything else other than that, other than the you know uh, computation power that you set. So in fully managed service, you don't have to even set the computation power that is required. So this would scale in, or as and when the request comes in, and as and when the need arises. So that is the difference between managed and fully managed system service. So SQS is a fully managed messaging, message queue service, and it enables you to decouple and scale microservices or any distributed systems. So it helps in transmitting any volume of messages and at any level of throughput. And it also helps consumer to pull messages uh, from it from the system in a periodic fashion. And a message is intended for only one customer. So this service is built to cater um, one customer at a time. So one message is uh, at a time can only be handled by one consumer. So going forward, we'll see how it is different from SNS. So basically, the usage patterns are something like this. So you use it when you want to decouple your components within your architecture, and when you see that consumer is not always available, and uh, you want a decoupled system where the consumer, whenever it becomes active, can consume the messages. So basically, decouples interactive components from backend components. Um, the best example that I could give is if there are web servers that are communicating, they are very interactive in nature, and it could push some of the backend jobs or bad jobs to the backend components, and backend components could take its own time to execute those requests, and it would do certain operations based on the messages. So this the other usage, as I told earlier, is a batch messaging for future processing. So there is also a concept called poison pill messages and dead letter queue. Basically, what it means is whenever a message is not processable, or when message is not understood by the consumer, what it can do is it can put the message back to another queue called dead letter queue, which is this queue would be basically associated with your standard queue which you have created. So there are your queues, regular queues, and dead letter queues. And dead letter queue would basically consume certain messages which are not processed by the consumer. And also, dead letter queue have few more capabilities. We will see that in a moment. So whenever you're pushing a message to the SQS queue, it can be in JSON format, or it can be in XML format, or it can be any unformatted text, and it also supports some of the Unicode characters which I have mentioned here. Sorry, which I have mentioned here. So other than um, these characters and formats, other characters are not permitted in SQS. So body contains these messages, that is XML, which is in XML or JSON or unformatted text, and also Unicode characters, which I had mentioned in previous slide. And it also contains attributes, and this attribute contains key value pairs kind of code, kind of values, and this attribute can contain uh, values which holds business meaning or technical meaning. It could hold both of these information outside the actual message body. So as in when you create a message, you could associate the message with a body and attributes. So what's the difference between these two? So why can't we use uh, why do we have to use technical meaning or business meaning outside the message body? Is if you want to you know route these messages, or if you want to process these messages in before even looking into the actual body, then you could use these attributes to process those message. Or let's say if you want to, if the consumer uh, want to process only certain set of messages, as mentioned here, in this diagram it is depicted that you can send different set of messages from different producers, and consumers can be many, and these consumers can actually process those messages based on the message attributes also. So you could use message attributes to um, kind of filter those message processing. And one important differentiator is messages can be encrypted, but attributes are never encrypted. So you can set server side encryption to SQS, and all your messages can be encrypted, and but you can never encrypt these attributes, message attributes. So there are two types of messaging queues. One is standard and other one is FIFO queues. So standard queues are basically, these were created at the very beginning of SQS, and this gives you ultimate throughput, unlimited throughput. It doesn't have any restrictions for your throughput, and they give you best. They get the best effort in ordering, but they are not delivered always in the order, and this gives you at least once delivery. So there might be a chance that you could have multiple records within the queue, and also at the time of delivery. So uh, you have to handle manually or within your application for the duplication, both within the queue or at the time of delivery also. So FIFA queues provide you limited throughput. That is, it can send up to, you know 300 operation. It basically, it has it can give you 300 operations per second, whether it is send, receive, or delete. So if there are 150 message being sent into the queue and 150 message which are being processed, that is the max uh, throughput that it can provide. But what you could do is, if you use batch processing, and you could batch up to 10 messages per operation. So you could go up to 3000 messages per second. So basically, this FIFQ means first in first out delivery. So it believes in ordering of the messages. So all the message are processed in order, and it provides exactly once processing, which means that a message is delivered once and remains available until a consumer processes and deletes it, and duplicates aren't introduced in the queue. There is always a possibility that duplicates are introduced in standard queues, but not in FIFO queues. And it also has uh, message grouping uh, pattern, where you could group messages within the queue, and a particular uh, consumer can target that message group and process those messages. But again, uh, everything combined can give you maximum of 3000 messages per second throughput. Yeah, so basically the concepts we discussed earlier: at least once delivery. FIFO gives you exactly once processing. So there are no duplication message sent to the receiver. To avoid the duplication, or to deduplicate, what we could do is, it provides um, two different approaches. One is content based deduplication ID, and producer provided deduplication ID. So you could set the deduplication ID within the content and as an attribute as well. So message grouping ID is basically used for order preservation within the message groups, and uh, dividing the um, messages based on the groups. So your consumer can target those message groups and you know process them. So you could have multiple message groups within the single FIFO queue. So there can be only one consumer which can have in-flight messages in a messaging group, and multiple consumer can access messages in different messaging groups, but uh, only one consumer per messaging group. So these are particularly helpful if we have uh, let's say there are three consumers who are uh, I'm sorry, there are three orders which are in different messages groups, and each order has, let's say, five messages, and the consumer can um, process those messages by choosing that particular order and um, processing it. And messaging groups can be created dynamically, um, uh, and it is scalable in nature, and the scalability is endless, so you get unlimited scalability in terms of creating messages groups. So one of the patterns um, here you could do is, if you are building uh, a, let's say a e-commerce website and there are a lot of orders coming in, and you could put um, uh, you know you could create a message group per order, and let's say if there are five messages which are related to that order, and these five messages are executed uh, in an orderly fashion, which are part of one single message group. So that is also a pattern which is chosen while using this FIFO queues. So let's understand some of the functionalities of SQS. So it gives unlimited queues and messages, and payload size cannot be more than 256 KB, and each 64 KB is billed as one request. And if there is a SQS extension client library for Java which helps us store up to 2 GB of storage in S3, and that would refer back to this message. So if you have more than 256 KB of storage per message, then you could use this extended library to store the remaining content, store the actual content in S3 and reference it back to SQS. So that is a useful tool if you have more than 256 KB. So each messages can be grouped into 10 messages, and it can be batched, but it has to be max of 256 KB. So there is a concept of short polling and long polling. So short polling is basically as and when the message comes, uh, you could the message is ready to be used, and long polling is basically uh, whenever you request to the queue, and it would wait up to 20 seconds to respond um, till it gets the message. So if there are message already available in the queue, it would immediately respond. But if there are no messages in the queue, and you are trying to pull the message from the queue, then it would wait for 20 seconds to respond. So this gives you you know good performance in terms of number of requests that goes between SQS and your consumer. So consumer asks this SQS, and if there are uh, messages available, it would immediately return back. If it is not available, only then it would wait for 20 seconds to respond back. So it's a very good feature to enable it. So as in when you are configuring SQS, you won't um, see the option set already. You have to do it manually. So basically, the uh, period to return back the request would be set to 0 seconds. So you have to increase that for long polling. So basically, the default period for retaining the message is 4 days. You could extend it up to 14 days. So the messages can be retained up till 14 days. You could send and read um, messages simultaneously, so there is no uh, restrictions for you to um, uh, say that, like, if the messages are sending, you cannot read it, so you can do simultaneously. And as I told, if you're using FIFO queues, there is a limit for that number of operations to be performed. So whenever the message um, is received, the consumer, the message is locked for processing. So what it means is, when a message is being still processed by the consumer, that message will not be consumed by, or will not be visible to other consumers. So once the message is consumed by the consumer and consumer deletes this message, uh, or the validity timeout, visible timeout period expires, till then the messages is locked. So you could also um, share the queues. So you could share it with anonymously or with specific AWS account, and it can be also restricted by IP address and also time of the day and all that. So there are you could tweak the sharing options. So another functionality that I mentioned earlier is you could use uh, a server-side encryption to encrypt your messages, and you could also handle the messages which are not successfully processed by the consumer with late letter queues. The basic uh, states of messages are, uh, there are like three basic states. So one is, you send to a queue by the producer, you receive the message from the queue to the consumer, and the next state is you delete uh, the message from the queue. So the message has goes in three different states. One is to you know, from the producer to the consumer, and a state where it gets deleted. So when a message is considered to be stored, or which is sent to the queue by the producer, then uh, uh, you know it would be a stored state, like it is not yet received by the consumer, but it is stored in the queue, and this would be somewhere in the 1 and 2 state which we discussed earlier. So there is no limit for number of stored messages, though they say this, they have told that there is some limitation somewhere around 12.5 million messages, which I have noticed, which I have read somewhere. So there is a limit of 12.5 million messages, but they they have mentioned in the documentation that there is no limit for this. So the message can be considered to be in flight when it is received from the queue by the consumer but not yet deleted. So basically, when the message is not visible, um, and which is still processed by the consumer, the message will be in flight mode. So there is a limit to the number of in-flight messages that you could check in limit section of messages. There are different limits for standard queue and FIFO queues. So we would check that. So to prevent other consumer from processing the messages again, SQS sets the visibility timeout for a particular message that is being processed. So the default is 30 seconds, and you could set the visibility timeout up to 12 hours. So here's just an illustration when the message is requested and message is returned to the consumer at that part of time, and the visibility timeout period starts, and any request for that particular message is not returned. And when the visibility timeout expires and there is another request, then message would be returned. Here's an illustration of message lifecycle again. So component one is basically a producer. Producer sends a message. Messages are stored redundantly. To understand that the messages are not stored in just one system. SQS is a distributed system, and it is stored in a different uh, storage devices, and uh, it would be part of the queue. And when the consumer, the component 2, receives the message or tries to read the message, visibility timeout clock starts, and that a message is not visible for any other components. So when the component 2 process that message A, then it will delete. It has to delete the message from the queue during the visibility timeout period. If it doesn't delete within the visibility timeout period, then there is a chance that other components, which are consumers, which are out there, can process that message because it is visible to the consumers. So there is also a retention period, which I said earlier. You could change the retention period using set queue attributes action. So there are some of the benefits from Amazon SQS compared to other options, other messaging service which are available. So basically, it provides server-side encryption, and it is stored in multiple servers. So there is high durability, and it provides high availability because it also stores in a redundant infrastructure. So whenever there are more producers, uh, the messages are not stored in the same systems or same distributed systems. There can be 100 distributed systems, and messages can be stored in first four servers, and the next message can be stored in different four servers. So there are large number of systems which can take in the message, and lot of high concurrent access uh, is possible. So this could also mean that you get high scalability, and it also uh, increases. It can take load increase or spikes without even you enabling or you provisioning any configuration. So scalability is built in again. So it also provides reliability. It can send multiple messages and multiple consumers can receive it. And there is also customization in terms of you know the default delay in the messages, which you could configure. And there are many different configurations that you could customize, like the message size, um, and how the message has to be split into smaller messages to form into a larger message, all that. So there are a lot of customization built into SQS as well. So there are some of the yeah, these are some of the common design patterns which are used with SQS. So basically, work queues are commonly used where it decouples components of distributed applications, and SQS can be used as batch operations where whenever you uh, require scalability or reliability to your architecture, you could use uh, buffer and batch operation. So there is also a pattern called request offloading. What it means is you could move the slow operation of the interactive request path. We will see how it is done, uh, you know, in a few more slides. So there is also a fan out operation where you could send identical copies to uh, multiple queues in parallel. So you would take the help of SNS to achieve it. There are also priority based models, patterns, where you could create a separate queue based on the priorities, and you would direct those messages based on the priority, and it would be processed. It also There is also a scalability pattern where uh, you could scale up the send or receive rate of the messages. And there is also a um, resiliency pattern where even if your backend system goes down, the messages are still part of the SQS, and it can be processed when the backend systems are um, active again. So it provides excellent resiliency. So these are some of the design patterns. So let's see some of the illustrations of some of these patterns only. So uh, auto scaling Amazon EC2 with Amazon SQS is one of the common patterns which are used, where whenever the web requests um, need some um, batch processing, or when you need auto scaling performance which are performed in as a backend job, then you could use this pattern where queues are you know used as to capture the request, and that would direct to photo processing servers. And these photo processing servers can be it can be in any scale. So as and when the request comes in, you could find the or your CloudWatch can find out the size of the request, and based on that, EC2 instances can be um, spinned up, and the scale of the EC2 instances can be dependent on the size of the queue. So here's an example where there is a five uh, instances, five messages which are queued, and there are let's say there are six photo um, instances which are out there. This is just an illustration, but there could be many messages and many uh, photo processing servers. These messages would only contain the references for that image which are present in S3. So photo processing message, photo processing servers could get the probably the URL for the S3 bucket, S3 object, and it would fetch the object from the S3 and it would process, and the response can also be put back in the another queue called response queue, and that would be processed by the web servers as well. So these are decoupled systems. So this doesn't follow request and response pattern, immediate request and response pattern. So this request and response uh, are not immediate in nature. So that's the thing we need to understand. So again, there is a pipeline processing pattern where, uh, let's say, there are images which has to be processed in different levels. So you could have a processing server A which does level 1 of processing, and you could again push that to uh, a next queue where there will be second level of processing, and you could chain up such pipelines and process the request and give the response as well. So this is a pattern where you want a decoupled environment where different levels of processing is taking place and a response has to be returned back. So here's just an example again. So booking takes place around 3 seconds. Here it is uh, broken down in terms of number of seconds that it would take. So a change status in database would take only 30 milliseconds, but the other process would take nearly uh, 1 second. So half a second. So 1 second, half a second. So basically, what you could do is you could separate those tasks, and you could respond back immediately once the uh, change of status in the database, and you could this would be an interactive synchronous system where it would respond back to the user saying there is a change in the database, and the message is stored in a queue, and the next background job or a next component or consumer can read the message from the queue and start processing the next set of jobs. So this would helps in breaking down the synchronous latency with asynchronous tasks. Here's again another simple pattern. So if you are having um five um, you know servers in the front end web servers, and you have two application servers and which is connected to DB, and there are um, two ELBs, but you want you are looking for a distributed system, then you could use this pattern where SQS can be placed in between. So when you use this is because whenever you use this, there won't be a synchronous communication between your web application and the database, but it would the background jobs are happening are not actually notified immediately to your web servers. You could use this pattern as well. So there are some pricing options which are available, uh, which are mentioned here. I'm not going to go through all of them. So there is also a simple notification service, which is basically fully managed PubSub messaging for distributed systems. So this would basically give you a pattern where there are many publishers, there are many subscribers, and there is no one message, one customer here. There will be many one message, one consumer. There are many consumers who consumes the same message which are put as part of this service, which are uh, from the publisher to the consumer or a subscriber. So this is basically a fully managed push notification service, and it follows the fan out patterns. It says so individual messages or fan out messages to a large number of recipients. So basically, it caters with SQS. It delivers message to SQS, Lambda, HTTP endpoints, and also it can send emails, and it can do um, SMS delivery as well, and push notification service to your mobile apps as well. So there are mainly three components here. One is basically publisher who sends messages to the topic, and there are subscribers who receives the message from the topic. So the subscriber can be all of this which are mentioned here. So this is how it works. Basically, a publisher sends a message to SNS, and these messages uh, are uh, part of a topic which publisher has mentioned. So it would go and sit in a particular channel. Topics are nothing but a channel, and uh, this channel would also have some message filtering option, where this message filtering option is configured to the subscribers, and these subscribers receive these messages based on the message filtering. So there can be different subscribers with different message filtering options, or it can directly get all the messages from the topic as well. It doesn't have to always go through message filtering. You could configure um, it, or you could customize it to go through message filtering or directly the topic. So there are these are some of the subscriber protocol. One is email, SMS, HTTP, HTTPS, um, SQS. You could configure it to SQS, and push notification to mobiles, and AMD Lambda invocation. Some of the usage scenarios are fanning out. So basically, fan out means it's like a broadcasting to all the subscribers which are available. So it just broadcasts messages to multiple consumers. Other usage pattern is application and system alerts. Whenever there is a we saw that last time we configured an SNS for a billing alert, where if we had crossed the $15 billing mark, it would send an email as a notification. So we could use you could use SNS for those scenarios as well. You could push text messages and emails. You could use for app mobile app push notifications. These are some of the usage patterns. So there is something called as fan out event notification. So you could during the fan out event notification you could combine SQS and SNS, and you could parallelly process asynchronous messages. So you could use this fan out event pattern. So you could also send SMS messages directly to phone or uh, to multiple phone numbers. There are different message types that you could use, like basically a promotional and transactional. So transactional basically are expensive in nature and they are more high reliable, and these are basically critical messages. So they are little expensive in nature, and you could set a monthly spending limit, and this is available in over 200 countries, and you recipients can opt out of this messaging service as well. SNS for SMS messaging is supported by um, only these six regions. As you can see, it is not supported in Mumbai region, but you might have to deploy your SNS topic there, and you might have to find a way out to find the do this message transaction. So if you have deployed all the applications in India region, that is Mumbai region, then it is difficult to achieve that. But only way you could achieve it is by deploying uh, SNS topics in different region and sending those um, messages to those regions and achieving that. So there is also whenever you're doing HTTP delivery, um, you could configure a delay between retries, because if there is any delivery failure, then you could set at what how many number of times that retries have to happen, and back off function that it has to use. It might be linear or exponential. So linear, as you know, it would take if you set 5 seconds, for every 5 seconds it would um, uh, keep retrying, and if you set exponential, then it would exponentially uh, like 2 4 16 or 8 16, something like that. It would use those functions to do the number of retries. So you could define retry policy at topic level or individual subscriber level also. So you could use message filtering option to do that. So you could set message delivery rate to throttle the delivery rate. One of the fine features of this is spam protection. So what it does is uh, if you are providing an endpoint for the HTTP or email, there is subscriber has to confirm the subscription. So this would help customers from populating the flooding the emails unless the consumer requests it for. So it also has SQS model for confirming the communication between SNS and SQS. So if the owner of SQS and SNS are the same, then um, it is automatically confirmed. If both are different, then if the owner is request if the SQS owner is subscribing for the topic, then owner of the uh, topic has to confirm, and same goes with other way around. So this is just a step involved in filtering my messages published to topics with SNS and SQS. So SNS push the message to topic. You could filter the message, and based on the filter, the consumer can consume. And there is also a pipeline where SQS reads those message and publish it to Lambda, and uh, it could perform a DynamoDB transaction. So there are different pricing for each type of endpoints, and there is a free tier for it as well. So this free tier is based on month, and you get 1 million free messages per month for mobile push notifications. And you get emails 1000 as part of free tier, and HTTPS requests for 100,000. So for monitoring SNS topics using CloudWatch, I've attached a link. There are a lot of metrics which are captured and which are enabled, so please go through that. This is basically how SNS can be configured to Lambda, and SNS, SQS, and Lambda can together be configured. So basically, you could see the difference why SNS are not directly communicated with Lambda. One reason is the message retention period is up to 13 hours, and you could get, if you use SQS, you would get more message retention period. And if say message once the message from SNS is delivered to Lambda, Lambda doesn't have to go back and delete the message on successful processing. So once the message is delivered, the message is deleted even if processing is not successful. So if you want, if you are uh, the request is critical, and the you are reliable on the successful success of the message or of the operation, then you should use SQS um, in between SNS and Lambda services. So we saw what SNS offers. It gives you multiple endpoints, and it is customizable in terms of deliveries for HTTP. So you could set different kinds of backup algorithms, backup functions, and how many number of retries and things like that. On failure of the notifications, you could use metrics um, or CloudWatch to monitor that as well. And whenever let's say it is configured to HTTP, and if the endpoints are not active, or if it is not able to deliver, you would get a notification for it. So it can be integrated with with many AWS services such as Lambda or SQS, or many systems, many services. So queues are also some of the features of queues are long polling, server-side encryption, data queue, um, easy monitoring, and it also gets integrated with many AWS services. So let's quickly see the services. So SNS, as we saw earlier in billing session, we could create a topic, and we had created uh, a billing alarm topic. So this was sending an email. This was using email protocol to send messages to my email whenever the bill exceeds $15 USD. So there are push notification um, options where you could create, based on the platform. Like it can be Android, it can be iOS, it can be Fire Stick OS, it can be many other platforms. So you could send text messages as well. So there are some more option where you could subscribe to a topic. So basically, we will go through the queues quickly. So I have just created a STD queue here. This is We'll create a new queue. We could create a standard queue or a FIFO queue. Uh, I would say STD1 queue, and let's see some of the configurations that we can do. So we could set the default visibility timeout to 5 minutes if you want. Message retention period to maximum of 14 days. You could set the message size between 1 to 256, but 256 is the max. And you could set the delivery delay, where this is something like how many minutes you want to delay to reach the customer or see the consumer, right? So there is also receive message wait time. This would set you the long polling feature. If you set it to 20 seconds, it's basically you're setting the long polling for it to um, receive the message or receive and wait for the response. So you could use a redrive policy. So redrive policy is basically like, let's say if the messages are there are a lot of duplicate messages which are hit into the SQS, and you want to uh, drive those messages into dead letter queue, then you could use this redrive policy. And it is also, if the messages are not processed, then if there are poison pill messages, then you could uh, target the you could enable the dead letter queue. So whenever you enable use redrive policy, you could use dead letter queue and receive maximum receive of these messages. So you have to mention the dead letter queue here, the name of the dead letter queue. If you have already created, you could always go back and add this queue later part of time. You could use SSE, that is a server side encryption. For this, it could be default, or you could enter a customer managed key, ARN, if you have a customer master key. And you could set the data key reuse period, so it would rotate this key based on the duration that you set here. So I'm not going to use the retry policy. I can just go and create it. So all of it is you know configured for this. So if you want to exclusively give permission for a particular resource, then you might have to add the policy here, allow and whether it is everybody or a particular account number, or what is the action that you can do. So uh, you could add the permission here. If there are any dead letter queue configuration, you could do it here. So since I have not enabled dead letter queue, um, you could not add any queues here. So basically it monitors what are the messages that are here, and you could add tags, you could use encryption, which I've enabled. You could set the trigger for lambda here. So for everything else, it is a uh, pull mechanism of the messages, but for the lambda, it whenever a message comes into SQS, it would trigger the lambda. So it would use kind of event trigger mechanism. So whenever the message comes in to SQS, lambda can know and start processing those messages. So if you're not using lambda, then you might have to request to the SQS to pull the messages from the queue. Okay, so let's see what we can do. We can send messages to the queue. We can delete the messages, particular messages. We could configure the queue we want. So we could set the read rave policy here. We could set the queue here for that. All that. So let's send a message here. I would just say hi all. I could set the message attributes anything, right? So I told you this would not be encrypted at all. Okay, so you could say name and standard and say send message. So messages is sent, and if you want to see could see start polling the message. So there is a message called hi all. You can see this message here. So there's a message which is out there, and you could delete that message, and could see more details about it. You could see the message attribute also. There's something called as go learn. You could delete the message. So it stopped the polling, and you could start again if you want. So basically it would show how many messages are there. If the messages are read, how many messages are in flight mode, and how many messages are available. So you could use this message available um, size to determine the auto scaling capability of EC2 instances, to figure out how many instances has to be available to process these messages. So you could purge this queue, or you could delete this queue. You could subscribe to SNS topic. What you could do is, let's say I have a topic here. You could go to this $15 USD exceed queue, and you could subscribe. Any messages that comes here can will be published to this standard queue, and you could process the message here as well. So you could configure lambda function. If there are any lambda functions which I've created, you could see that there are many. You could just configure that. So as and when you send the message, this lambda would be triggered. So I'll just so it says that execution role does not have permission to do this, so it was not created. So you might have to go and do that. Sorry, I'm not going to do it now, but basically you could configure trigger of that lambda there. Yeah, basically pretty much uh, that's it. So basically we saw how we could send message, we could view and delete message. So whenever the messages are consumed, it would be in a in-flight mode, and it would be mentioned here, and all the messages which are available in the queue would be mentioned here. So you could also use a content-based deduplication, which is not available for standard queue. If you're going for FIFO queue, you could have see that. So yeah, why not? Let's create a FIFO queue. So you have set the you could set the content-based deduplication, or um, otherwise. So you need to have uh, um, a dead letter queue for it to be activated. Could also set a content based um, duplication. So these are some of the default parameters which are set.